Alright, so in this video we're going to talk about imaginary numbers. Now we say imaginary, and I have students sometimes who ask about why we are learning fake numbers. Imaginary numbers are not fake. They do have real-world applications. Just as one example, they use it in electrical engineering with they're dealing with alternating currents. In fact, any type of situation where you have what's called periodic motion, you might end up dealing with imaginary numbers. But that's not what our focus is, so let's go back to the math part. Imaginary numbers are represented by a letter I, lowercase I, and it's equal to the square root of -1. And pure imaginary numbers are always written in the form of bi, where b is your real part and I is your imaginary. So, let's take, for example, the square root of -25. This is technically the square root of -1 times the square root of 25. Square root of 25 is positive or -5. Square root of -1 is I. And honestly, you can skip this step. You see the square root of a negative, that means it's imaginary. It means I'm going to have an I in the answer. So, square root of -32, for instance. Square root of -32, well, I'm going to have to break that one down. 32 will break down into 2 times 16, which is 2 times 8, 2 times 4, 2 times 2. Now, 2 times 2 gives me 4, plus or minus 4, I because of the negative, and square root of the leftovers. One more example, and then we're going to move on. If I take square root of -7. Square root of 7 itself doesn't really simplify. The only thing I can do is take out the square root of -1 in the form of I. Now, imaginary numbers are also useful for solving quadratics with square roots. So if I had something like x squared plus 81 equals 0, this doesn't have any real solutions, but it does have imaginary ones. I start by subtracting 81 from both sides because you want your x squared by itself. This gives me x squared is equal to -81. When I take the square root, well, 81 is a perfect square. That's positive or -9. But this negative makes it imaginary. Okay, let's 4x squared plus 15 equals -9. Okay, one like this. Again, you start by isolating your x squared, the first step of which is to subtract 15 from both sides, giving you 4x squared equals -24. Divide by 4 to get x squared equals -6. Once you have your x squared isolated, you're going to take the square root of both sides. Now, if you were to try to break down 6, there are no pairs. So you can't really simplify it. The only thing you can do is pull out the I because it's imaginary. One more, and then we're going to go to the next bit. So let's say 5x squared minus 10 equals -90. Okay. So the first thing I'm going to do is I'm going to add 10 to both sides, which gives me 5x squared equals -80. Divide by 5 to get x squared is equal to -16. So, take the square root to get x equals plus or minus 4i. Now, remember, if you do end up with a solution that is not a perfect square, remember you do have to reduce your radical. So if you had ended up with an answer like square root of negative 32, you do have to rewrite that square root in the simplified form. Okay, so the next thing I'm going to show you is how to basically multiply the products of imaginary numbers. Okay, so before I do that, if you have an imaginary number raised to some exponent, you need to be able to figure out what that is equivalent to. Some of them are easy. I to the first power would just be I. I to the second power, well, that's where, that's a pretty common one. I'm going to show you an easy way to figure out I to whatever exponent, what it's equal to very easily. What you're going to do is, if you have I to some power, you're going to take your n value, your exponent, and divide by 4. And the reason we're dividing by 4 is because every fourth number on your exponent, we have a repeating pattern. You're going to divide your n value, your exponent, by 4. If your remainder is equal to 0, that I to whatever power is equal to 1. If your remainder is equal to 1, I to whatever power it was is equal to I. If the remainder is equal to 2, your answer for I to whatever power is going to be negative 1. And if your remainder is equal to 3, I to whatever power it is going to be equal to negative I. So let me give you a couple of examples. Well, let's take I to the 5th power. If I take I to the 5th power, to solve, what I'm going to do is I'm going to take the 5 and divide it by 4. 5 divided by 4 gives me 1.25. What I do is I look at the decimal, and I think of quarters. 25 cents, that's 1 quarter. Therefore, the remainder is 1. The remainder being 1 means that I to the 5th is equal to I. Okay. Let me show you some more. Let's say I have I to the 62nd power. Okay. I take 62 and divide by 4. This gives me 15.5. Well, again, I look at my decimal. 50 cents, that's 2 quarters. Remainder is 2. Remainder of 2 means it's equal to negative 1. Now, if it divides evenly, so let's say it's I to the 8th power. I want to figure that out. Well, if I do 8 divided by 4, it's going to come out to be 2. So what's your decimal? Well, it's 0. Remainder is 0. Remainder of 0 means this is equal to 1. So anytime you have I to some exponent, it can be simplified. And this is the quickest, easiest way to do it, in my opinion. There are a couple of other ways, but to me this is the simplest. Okay. Now, I went over this to show you some other ways of doing it, or to show you the products of imaginary numbers. So let's take 7i times 3i. At first, you treat it just like you would 7x times 3x. You multiply the 7 times 3 to get 21. I times I gives me I squared. Now, I squared is one you're going to see a lot. I squared is equal to -1. And this is one that occurs again and again and again when you're multiplying products, or multiplying imaginary numbers. And it's going to play a big part when we get to the next bit that we're doing. So this is not simplified, because anytime you have I to an exponent, you're not done. I squared is -1. So I replace the I squared with the -1, which means this is -21. Okay. So let's take, 2i cubed times 5i. Again, at first, you treat it just like you would if it was an x instead of an I. So the first thing I'm going to do is I'm going to cube this. 2 cubed is 8. I cubed is just I cubed. And then I still have the 5i. Multiply. 8 times 5 to get 40. I cubed times I is I to the 4th. Well, I to the 4th. If I take 4 divided by 4, the remainder is going to be 0. Remainder of 0 means that is equal to a +1. Which means this whole thing is equal to 40. So this is equal to 40. So imaginary numbers can sometimes come out to be real numbers. Okay. Let's see. Do a couple more. Let's take I square root of 3 squared times -8i squared. Okay. So, a square root and a square cancel each other out. So when I go to square this term here, 3 squared, or square root of 3 squared is just 3, and then the I squared. When you're squaring a negative, please remember it's a negative times a negative, so you need to get a positive solution. -8 squared is +64, and I squared, because this needs to be squared as well. Now, you can go ahead and multiply together right now, or since we know I squared is -1, we can go ahead and rewrite those. Either way, you should end up with the same answer. So if I take the I squared and substitute in a -1, I'm going to get -3 times -64. I'm going to put these in parentheses instead. Which means +192 is my solution. I would have gotten the same thing even if I had multiplied and then simplified the imaginary number. So whichever way ends up working better for you, go for it. Now, let's say it's not written with an I. Instead, it's written as square roots of negative numbers, like that. What you want to do first is take out the I. So I'm going to rewrite these as I square root of 18 times I square root of 10. Now when you're multiplying radicals, the numbers outside you multiply together. The numbers inside or underneath the radical you multiply together and leave it underneath. So at this point, what I'm going to do is I am going to take the 180 and I am going to factor that out. 180 I know is 2 times 90, which is 2 times 45, which is 3 times 15, which is 3 times 5. So pair of 2s, pair of 3s. and a 5 left over. So I can write this as -1, because I squared is equal to -1, times 2 times 3 gives me 6 square root of 5 on my leftovers. So the final answer is -6 square root of 5. It's no longer imaginary. Okay. That's it for today. Next time we're going to talk about complex numbers.